Okay, class, in this video, we're doing partial fractions case 3. Case 3 is irreducible quadratics. And what do we mean by that? So we know from all the stuff we've studied in polynomials that we can factor a polynomial down to linear and complex roots, so real and complex roots. We also know that if the coefficients are real, then the complex roots are going to be in conjugate pairs. So when I say irreducible quadratics, I mean things that give me complex roots in pairs. Okay? All right, my example is going to be 3x squared plus 5 over x minus 1 times x squared plus 1. Okay, so notice the roots of that are plus or minus I. All right, so the form of the decomposition would be a over x minus 1. And then for the complex, for the irreducible quadratic, we do the following. We say bx plus c over x squared plus 1. Okay, and just so we know, the repeated linear stuff, we had something over x minus 2 and something over x minus 2 squared. We could actually rewrite that as b times x minus 2 over x minus 2 squared plus c over x minus 2 squared. A similar kind of thing, so linear over quadratic. But it just so happens that we just want to make it simpler. So, all right, so if I do the numerator thing, so we get 3x squared plus 5, and then we get a x squared plus 1 plus bx plus c x minus 1. All right, and then there are a couple nice values. So 1 is the nicest. So when we plug 1 in, we're going to get 8. We're going to get 2a, and then that term is 0. This comes out nice. So a is 4. All right, the other nice term, it's not always as nice as it looks, but x equals 0 is kind of nice. That makes the b term go away, and I already know a. So over here, I'm going to get 5, and then I'm going to have a, and then 0 minus 1 is negative 1, so this is going to be minus c. Okay, a is 4, so subtracting 4 from both sides, I'm going to have 1 equals negative c, so c equals negative 1. And then, once again, I'll collect on x squares because that's kind of nice too. Over here I have 3. And then I'm going to have a x squared, so a plus bx times x is going to be bx squared. So once again, a is 4, so subtracting that from both sides, we get b is negative 1. So end result is that we can rewrite this as 4 over x minus 1 plus negative x minus 1 over x squared plus 1. Okay, and then on this video, I'll go ahead and go one more step further. So why are we doing this? Why are we doing this? Okay, so let's take a differential equation. And we're going to basically just take it and do some stuff with it. Okay, and I'm getting out my table of Laplace transforms. So we need an IVP, so we're going to say y of 0 is 2, and we're going to say y prime of 0 is 3. Okay, so I'm looking at my table of Laplace transforms here, and I'm seeing this last one. So basically I'm going to sub in n equals 2, so that's going to give me s squared times something minus s times f of 0, and then minus f prime of 0. So that's why we need the IVP. So in essence, I'm doing the Laplace transform of this whole side and the Laplace transform of 0 as well. Now that's easy. Laplace transform is e to the minus something times f, and f is 0, so the whole integral is going to be 0. So that's the easy part. Laplace transform of y double prime, as we just stated, s squared. We're going to say capital Y of s. In the future, I'm not going to write the of s. I'm writing it now just so you see it. But in the future, I don't want you getting confused and thinking that's s cubed. Okay, so this is minus s times y0, y of 0, which is 2, so times 2, and then minus f of 0, which is 3. So all that is the Laplace transform. So let me get the table out again, and you can kind of see. So all that is just this thing with 2 plugged into it. Okay? And then minus 3 And then the Laplace transform for y prime is going to be s y of s minus 2. And the Laplace transform for 4y is just 4y of s. Okay? So what we would do with this is we would get all the y of s terms, collect them together, and then put the other terms on the other side. So collecting y of s terms, I have this one, and that one. So I have y of s times s squared minus 3s minus 4. Okay, and on the other side I'm going to have, this is going to be negative 2s here, so on the other side it's going to be positive 2. I've got a minus 3, and then I've got a negative 3 times negative 2, so that's plus 6. So altogether that's negative 3 on the left, so it's going to be, sorry, positive 3 on the left, so it's going to be negative 3 on the right. And then we would solve for y of s, so divide by everything, and we get y of s equals 2s minus 3 over s squared minus 3s minus 4. Okay? And look, that's most of it. Then you do your partial fraction decomposition and an inverse transform, and we'll go from there. All right, that's it.